Hello, everybody, and welcome to the Mathigon Back to School webinar. My name is David Poras. I am the head of content at Mathigon and a 7th grade math teacher outside of Boston, Massachusetts. Here we are at Mathigon.org. As you may know, Mathigon.org is interactive, personalized, and free. We are excited to offer all of these tools and activities I'm going to show you tonight free for teachers and students around the world. I'm going to go through a number of ideas of how you could incorporate these tools into your teaching at the elementary level. If you have questions along the way, please feel free to put them into the chat. I will answer the questions as I see them. I also, at the end of the webinar, I have about 45 minutes planned of ideas to share. I might go a little bit longer as I get excited with all the cool things I want to share with you. But at the end of the webinar, I will take time to answer any other questions that you have. And it's great to see people dropping into the chat where they are in the world. Alabama, Toronto, Australia. Awesome. All right, I'm going to get rolling here. Here I am, as I said, at Mathigon.org. I'm going to go to Polypad. So on the top of the Mathigon.org, I'm going to click on Polypad. And we like to think of Polypad as an open canvas for students to explore mathematics. And so this white space I'm going to call the canvas. Over here on the left is the tile panel. You can see we have a number of categories: geometry, numbers, fractions, algebra, probability and data, tools, and axes. I'm going to start with the number tiles. And if you've played around with Mathigon before or been to one of these webinars, you know in the number tiles there is the 100 number tile, the 10 number tile, and the 1 number tile. I'm going to zoom in with the tools on the right. And as you explore on Polypad, you'll notice anytime that you click on a tile on the canvas, a number of options could appear on the tile, like a black handle, and a number of options will appear at the bottom of the canvas. So I just want to show you this black handle. When I click and drag, the 100 tiles are the arrangement of the 100 tiles. It changes as I drag here. So I'm going to turn on a grid background to make that a little bit clearer. Here it's 10 by 10. I can drag over and see it's 11 by 9 plus 1. I could make it a 5 by 25 and so on. And that obviously works with the 10 number tile as well. There's 5 by 2. So a great way for students to explore factor pairs of numbers is just by clicking and dragging with the black handle. I'm going to turn off the grid background for a moment. And I want to show you the other option. I can click and drag. First I'm going to click on the 100 block. And now I'm going to show you what happens when I split the tiles at the bottom. So as I was saying, when you click on a tile, buttons will appear at the bottom of the canvas specific to that tile type. So I click on split, and now I'm going to select a group of 20 and delete those tiles. I can hit the delete button on my keyboard. There's also an option at the bottom. So now I have 80. I'm going to take this one and move it over, click and drag to select all of them and merge the tiles. And now I have a group of 81. And you can see this is a 9 by 9 square. I could make it into groups of 3. I could try to make it into groups of 4. When I make it into groups of 4, I could split them and make this a different color to show that groups of 81, I could put back on the grid and show that it's 4 groups of 20 plus 1. So it's also nice to be able to use the colors to show what is left over when you take a number like 81 and split it into 4 groups. So that is super fun. Let me go back to just a blank background. I'm going to click on the tile to add it to the canvas. Here's a group of 10. I'm going to be copying tiles a lot in the webinar. 2 ways to copy tiles. There's a copy button at the bottom. You also can just use the C button on your keyboard. So I click C twice to copy those. Again, this is a group of 40. So I've done activities where I have students take any number that they want and show all the factor pairs of that number. So I'm just using the C button on the keyboard to make copies of them, and I can have a great time exploring factor pairs of those numbers. What's also nice is, I think a real exciting part of Polypad that I've incorporated into my teaching a lot over the past year is the ability to add different tile types onto the same canvas. So here I've just been exploring with the number tiles, but I'm now going to go to the number bars and frames. And I can see here that I can take the 10 number bar and put it right on top of the number tiles to show that that's a group of 10. Obviously, here's a group of 5. Those colors, if you've been using Cuisenaire rods with your teaching, those colors might not be the colors you prefer to use. And so over on the far right under settings, a few options here. I can hide the number labels so there aren't the numbers on the bars anymore. And I can also choose some a different color scheme. And when I choose a different color scheme, those might be the ones that you prefer to see on the number bars. Here are number frames. Oops, I swiped instead of dragged. Here's a number frame. So there's a group of 9 and a group of 3. And again, it's really nice that the sizes of those all match up with each other. So we've looked at the number tiles, bars, and frames. I just want to show you a quick way that I could create an activity with students here for them to engage with these tools. I'm going to go up to the File tab, and one option on the File tab is this button here to create a new Polypad. So I'm going to click on that. I don't want to save these changes, but I appreciate Polypad asking me before I move on. I'll show you how to save changes in a minute. So I'm going to add some text onto this canvas. I just want students to add the numbers below. So I'm just going to show you how to make 3 quick questions doing addition with students. Maybe the first thing I want them to add would be a group of 7 tiles. So I'll split these and get rid of 3 of them and then copy 5 of them. I'm just using the C button on my keyboard and I'll make those a different color. So there I've just made the question 7 plus 5. But I'd like to add a number line to this canvas to help them if that's a tool that they would find helpful. So under Tools and Axes at the bottom, I'm going to add a number line. And you can see I can drag the number line in place. It looks like the spacing of the number line doesn't match up with the number tiles. And so when I click on the number line, you may have noticed a menu appears over on the right. So I'm going to change the width to 1. And now it matches up really nicely. And I'll extend it up to 20. And if students want to use the number line to help them make sense of that addition problem, they it's on the canvas there to help them. I'm going to add a question builder box. If you are exploring Mathigon either as you're watching the webinar or on your own, I'm right now in a teacher account on Mathigon, and so a few features only appear in teacher accounts. One of those is the question builder feature. The other feature that I'll show you in a minute is the class tab. So again, I'm in my Mathigon account. I'm in a teacher account. I can see that because it says that I have a teacher dashboard. If you first made a Mathigon account and made it a student account, you can change it under account settings. So here I'm going to put the answer of 12 because I think 7 plus 5 is 12. And so this is a question builder box that only is going to appear on my version of the Polypad. When students get it, which I'll show you that in a second, they're just going to see a question mark there. So let me add a couple other questions here. Maybe I want them to add a number tile. I'll split that and maybe make it 4 of them. I just want to show you how easy it is to make questions like this. Maybe I'll do 4 plus 3 plus 9. What's that? 16, but I'll give them a number line if they want to use the number line as well. And I'll also add the question builder here of 16. And the last one, I'm just going to do some number frames. Maybe we'll do 9 and 5 and 4 and 1. So 9, 5, 4, and 1. I'll change that color to make it a little bit clearer on the canvas. Here's the number line as well. What's that? 9 and 1 is 10. 19. Did I do that right? 9 and 5 is 14 and 4 is 18 and 1 is 19. I think I did that right. It has been a long day for me as well getting my classroom ready, so I apologize for any calculation mistakes along the way, but I think that is 19. And before I show you how to share this with students, I just want to share a new tool that we've added, which is clocks. So there's a live clock. Here you can see it's 7:12 in the time zone that I'm in. I'm going to get rid of the live clock. Here's a geared clock, which as you move the hour hand, the minute hand moves appropriately, and there's a second hand as well. I'm going to choose to not have the second hand on this clock. So as I said, when I click on that tile, one of the options at the bottom is to toggle seconds. So I'm going to toggle that, it's gone, and maybe I want students to tell me what time this clock is. So I'll just say, I'll get it at 9:30, and I just want to show you this also works with the question builder tool. So I'll just put in 9:30 here. All right, I've made a canvas that I'm ready to share with my class. So first thing, I want to save the canvas. I'm up in the file menu now, and I'll just say addition practice, and I'm going to save this canvas. Now, before I do it here, I just want to share with you that on up at the top, if you're in a teacher account, and you click on For Teachers at the top, I just opened it in a new tab, there are a number of videos in the tutorial section that show you in detail what I'm about to do really, really quickly. It shows you how to make classes and add classes to the students. It shows you how to share Polypads with a Mathigon class, how to share Polypads to Google Classroom if you use Google Classroom as part of your teaching, how to share Polypads with just a link, and how to use the question builder tool, which I just was doing as part of my example. So, all right, back to my Polypad, and I've saved this. Now I'm going to assign it to a class. In this Mathigon account, I just have one class, boringly called example class. If I had multiple classes, they would all appear here. I'm going to assign it to my example class. I've shared this with my class. One of the students in my example class is my daughter, so I'm going to swipe over to her Mathigon account. There she is. Her name's Emily. She's starting 3rd grade. And I'm going to go to Polypad under her account, and you can see now there's a folder here called Assignments. And when I open that folder, there is the canvas that I just made, Addition Practice. And you'll notice those are all the question marks now. So maybe she wants to take these and move them up. Maybe she wants to take all of these and move them down to help her, and then put these over here and see that, oh, that adds up to 12. Oh, but I typed in 11, so it tells me I got it wrong. And then I get 12 and I get a green check. What's that for? Oh, you know what you could do is move one over here to make 10, and then see that that's 6. So there's 16, I get a green check. Maybe she could spin this if she wanted to and see how those all compare to each other and go through and get the answer. And I just want to show you what happens when students get all the answers correct. They get this nice confetti coming down on the screen. And my students always enjoy getting the confetti to come down on the screen when they get them all correct. She needs to save a copy of her work. So I'll click Save Copy for her. I want to go back to my teacher account here. And when I hit, when I give my canvas a refresh, 2 things appear. One, I'm going to turn on names. So I can see here that this first canvas is a copy of the assignment, the blank assignment. And here on her Polypad, when I click on her name, I get a copy of her canvas. I can see she got these correct. I thought I got 9:30 here. So we might have a little glitch with the times and the clocks. I will add that to our to-do list to figure out. We just added clocks in the last week, so a little glitch there to figure out. Let me give it a refresh and see what happens. Yep, we'll come back on that and get that fixed. But I can see here now as a teacher, apart from the clock feature, that she got these correct. More importantly, I can see as a teacher how she thought about these questions. I can see that she took the 1 and moved it with the 9 to make a 10. I can see that she thought it was helpful for her to put these tiles on the number line. I can toggle on and off names. If I had a lot of students here who approached maybe question 2 in different ways, I could share that with the class and again have names on or names off as I like. So really easy to make an assignment with the question builder tool. We do have some issues with the clock that we'll fix. And again, in the teacher page on Mathigon, if you just go to mathigon.org/teachers, it'll take you to this first page here, and you can click on tutorials, and there are videos explaining, as I said, how to make classes and share Polypads. So all of that is super easy to do. But let me keep going with Polypad here. If you have questions, put them in the chat. I will either address them as I go on or at the end. Kelly, that's great that your student said confetti made math like a party to them. That's awesome. Can you explain the color coding in the assignment? Yeah, so in green, anything in green, that means that a question was answered with the correct answer on the first attempt. When there's something in orange, that means a question is answered correctly but not on the first attempt. So that was on that first one when I typed in 11, I think, and got it wrong and then made it 12. That's what the orange means, and the red means that I got something wrong, even though I think I got it right. If I wanted to get a lot more information about each student, I can download all of the data into a CSV file and get the specific data for each student on the questions. So that's there as well. All right, let me go to a new canvas here, and I want to show you one of my new favorite tools that we've added this summer as well. It is the dot arrangements. So I'm going to go back to numbers. I'm going to go down to dot arrangements, and I'm going to type in the number 30. And so here's a dot arrangement of the number 30. Now, if I were doing this in school, I would do a lot of noticing and wondering and make a couple days out of this exploration that I'm just going to try to do in about 2 minutes here. But I'm going to add to the canvas here the prime factor circles. If you've played Prime Climb with Dan Finkel over at Math for Love, you're familiar with these prime factor circles. So these are made in partnership with him. Here is the prime factor circle for 30. And what I can kind of see here is that this dot arrangement of 30 is 2 groups of 3 groups of 5 circles. So I see in this picture that it's kind of like the 2 big circles, then the 3 smaller circles, and then 5 little circles inside of those 3 circles. Again, I would not go there immediately with students, right? A lot of noticing and wondering, what do you think is going to happen? But I just want to show you how these dot arrangements work. I'm going to copy it, and now when I click on the dot arrangement, one of the options at the bottom is reorder. So I'm just going to show you what happens, but again, I would stretch this out with students. I click reorder, and now, as you may see, the 2 goes in the back. Now it's 3 big circles with 5 of the medium circles and 2 dots in each of those circles. So when you click that button of reorder, the first factor goes into the back. And so now if I do this one more time and do a reorder, it should look like 5 big circles with 3 smaller circles inside each of those and 2 dots in each. And there it is. That's the reorder button. But then there are other buttons I want to show you what happens. The first thing that I want to show you when I click on this is combine factors. So when I click on combine factors, now it looks like 2 groups of 15. What happened? These 2 got combined. Ah, and there's the 2 groups of 15. That's so cool. I could see doing so many great explorations on this with students. And then I can take this one and reorder it. And now it's 15 groups of 2, right? Showing all the different visual ways to think about the factors of 30. I'll take this now and do the combine function because it's so much fun. I love doing it. Now I'm going to take this and combine, and now we should have 3 groups of 10. And there we go. So there is the 3 groups of 10. Oh, I missed. I'm trying to get this into place. Here's the 3 groups of 10. If I take this and reorder, we should have the 10 groups of 3. There it is. I got to finish it off because it's so cool. I know this is such a great, and like just the idea of students, just having students go pick a number and explore the dot arrangement for any number of their choice, see if they can make sense of it. And eventually students could make a picture like this for any number of their choosing. So I'd combine those here. It's 3 groups of 10. I could reorder and get the 10 groups of 3. And finally, if I take this one and do a combine factors on this one, it would be just a group of 30, right? Now, what I'm not going to show you too much in depth here is you also can take a dot arrangement. Let's just do a dot arrangement like 14, and you can pull them apart just like the prime factor circles and put them together. So there's 14, and then I'll put a 3 in there. Oh, and there's no option to combine or split or do anything. What does that mean? So what great conversations could happen with students about prime and composite and all kinds of numbers of factors. So those are the dot arrangements, super cool. I want to show you a few other things in the number section here before we move on to other tool types. I'll get rid of this canvas. I just want to add a balance scale to the canvas here. So I'm going to go down to algebra and put on a balance scale. And I just want to show you that all of the number types can work on the balance scale. So I could put number tiles on the balance scale. There's a 10. I could put an 8 over here, and that's not going to be balanced. But if I put the 2 number frame there, it's balanced. If I put 6 over here and 8 over here, That's not balanced, but I could put a prime factor circle of 2 to balance it out, and then maybe a dot arrangement for, what did I do here, 14. So then we could do a 5 and a 9. I mean, it just is so much fun making the scale balance. So again, I think there's great power for students here, creating that flexibility of thinking in numbers and lots of different representations, right? We talk a lot as teachers. I'm a middle school teacher, and it's key in middle school, but it's also much, hugely important at the elementary level to be able to think about numbers in lots of different ways. So just this picture on the screen, such a great way for kids to explore different ways to visualize numbers. The other things we've added this summer, yes, could this be used for K2? Absolutely. I think there's all sorts of examples that I've been sharing and will continue to share at the K2 level. We have an addition grid, which you can make bigger and smaller, and a multiplication grid. Again, you can make bigger and smaller, as I just showed. You can switch the directions, so the smaller numbers are in the bottom left versus the top right. But the one just quick thing I want to show you with these grids is just a number grid like this. I'm going to go up to 120. I'm going to make 2 of them here and put them next to each other. I'm going to change the color so they are about 50% transparent. So I'll make them each 50. And you make that 50. And then in the grid, I can double click on a number. I double clicked on 4. At the bottom, I can select all multiples of 4. I'll make those blue and make those a little transparent as well. And then on the other one, I'll do the same for 6. Make those red. Or I think I did an orange there, but that's okay. Select all multiples, make those red. There we go. Make them transparent. And then put them on top of each other, right? So we can see where those multiples line up, makes the purple, right? So, a great way to explore the common multiples of 4 and 6, right? And if I wanted to, I could expand it out. I just did the one on top. Let me do the one on the bottom as well, and then have them match up. And when I do that, you can see that all the common multiples in purple over there. So that is a great way for students just to explore multiples and what multiples have in common. I think that's a cool task for a lot of students. The other thing to share here is in the number and grid section is the multiplication grid. And what's great about the multiplication grid, it starts off as base 10 multiplication. Here's a block of 10 by 10, and you can make it bigger and wider and smaller and have students explore all sorts of area models of multiplication. But I also think it's great, this black dot in the middle, I can multiply in different bases without even calling it multiplying in different bases. So here, I'm multiplying in base 8. This is an 8 by 8 square. That's 8 squared is 64. Here's an 8 column, and that's still a 1. I could go to base 5. These are 25s and 5s and 1s. So I think that's a great activity for students to explore. I just want to share with you a quick example that I made with the multiplication grid for this webinar. Just a really easy multiplication grid with the question builder tool. So again, I, as the teacher, I put all of these blank question builder tools on the grid. I typed in the numbers. I'm going to save it here. I could assign it to the class. I'm going to go over to my daughter's account, give it a refresh, and you can see, oops, in her assignments, there's the multiplication grid with all the question marks as blank. So she needs to go through and think about what numbers at the top, what numbers down here, what's the area of those pieces, and what happens when you put them all together. Now, a couple of the features that I haven't talked about are some advanced settings for tile types. So on the right here, I have the box checked that says show advanced options. And when I uncheck that box, you'll see that the gear at the bottom is no longer there. But when I select show advanced options, that gear appears. And so I might be concerned as a teacher that my daughter could kind of move the multiplication grid and mess the whole thing up by accident. So there's an option back in my teacher account now where under the gear, I can lock the tile. And if you lock the tile, students can't do anything with that tile. It's like affixed to the background. So if I do a lock tile here, notice even as the teacher, I can't do anything with it. I can't click on it. I can't move it. It is locked into the background there. Now, for students and teachers under settings, there is the ability to unlock all tiles. So a student could do that. I found students don't often do it on purpose. They might move something by mistake or delete something by mistake and want to get it back. So I, as a teacher, could unlock it. And now I can, oh, I think I didn't click it. There we go. Now I've unlocked the tile and I can move it around. But just that ability to put the question builder tool on top of a grid, I think is a powerful tool for students. All right, just checking the chat. Yeah, the number grids could really help with choral counting. That's a great idea, Kathy. Awesome. And we can put the operations in the bottom left. Yeah, that ability to switch the direction of the number grids. I'm glad you find that helpful. That was a suggestion from a teacher at one point along the way. So as you explore Polypad and have suggestions, please share those with us either via Twitter. We've just launched a community page on Mathigon I'll talk about in a few minutes. But there are ways to get those ideas out to us, and we like to be responsive to the feedback of teachers. Last thing on numbers, I just want to show with you. I've been talking way too much about numbers, but certainly a big concept at the elementary level is getting students to think about numbers and visualize numbers in lots of different ways. In the tile types, under numbers here, there's a question mark, which will take you to an instruction page on all the number tiles. Right, so I'm not going to go through it, but that's the same in geometry. There's an instruction page. Fractions has an instruction page. And at the bottom here, there's a link to our tutorial page, which has links to all of those, as well as, if you're new to Polypad, a general overview of how to use Polypad, how to copy tiles, how to change colors, how to do shortcuts, and so on. So lots of tutorials available if you are new to this tool. And I know I'm going really fast. This is being recorded. You can always watch it on your own, but these tutorials can be helpful as well. And the final thing before I move on to geometry, under File here, we've just added a whole new section at the bottom called Examples and Templates. So under Numbers and Fractions, you can see there's a number of example canvases here, a 1 to 100 chart, fraction circles, which I'm going to talk about, fraction wall. So those are here under Numbers and Examples as well. All right. I'm having a great time. If you're still with me, hopefully you're getting some value out of this and thinking about some ways you could incorporate this into your teaching. I'm going to go to the geometry tools now, and I'm really excited to share some of the many things you could do with students in the geometry section. So first of all, in polygons, I'm going to go to the non-alternative colors. Yeah, right. So all of these polygons snap together really nicely. So I put the triangle with the square. Let me zoom in a little bit. So it has smart rotation and smart snapping. You can kind of see that as I drag them towards each other, they snap together really nicely. I could make a tessellation here, but in the interest of time, I'm going to stop making my tessellation, but there are videos about how we've made tessellations here. But what's great is all these snap together really nicely, right? So there's smart rotation, smart snapping. All of the polygons, except this one, I'll get to this wonderful polygon in a moment. All of these polygons are fixed in size, which means you can move them, you can spin them, you can change the color of them, you can cut them up, in fact, into different pieces. The cut tool is a great tool I'll be talking more about. You can flip them. You can't just like stretch, enlarge, or shrink them, but that can be done with the custom polygon tool. So this polygon here is the custom polygon. You can see it's a pentagon right now, but all of these black handles I can move in lots of different directions and make any type pentagon that I want. If I click on a side of the pentagon, I've added a vertex, and now it's a hexagon. Right, so I can make any kind of polygon that I want. I'm gonna make it a quadrilateral. If I click on a vertex, then I can make a quadrilateral. I'm going to answer that question I just saw in the chat about pre-made activities. So I have not shown you the task page yet. I was about to, but I'm glad you asked. So I'm also going to go to For Teachers in a new tab, and under lesson plans, so this again was in the For Teachers, and under lesson plans, this is our task page. I was just about to get there, but I'm thrilled you asked, because this is a great resource for teachers. We have about 85 or 90 puzzles, activities, and lessons planned for teachers. You can search by a topic. You can search by fraction. I could search for geometry. You could search by puzzles and games and see all the puzzles and games we have. You could do a filter by lesson plan, all sorts of great things to do in the task page. And I'm going to be sharing a number of those in the next 20 minutes that we have here. So thank you, Tanya, for that question. It was a timely question. This is our task page. You can get there by just going to mathigon.org/tasks. And I'm going to be sharing a couple of them in a few minutes. All right. But back to the polygon here. I've made a quadrilateral, and let's say I've made this quadrilateral and I'm really pleased with it. I don't want to have it like move around anymore. So one option at the bottom is to fix the vertices. I've clicked that, and you can see now I can move it and I can spin it, but I can't change its shape anymore. I'm going to copy it and rotate it around and stick it on top of each other. And you may know any quadrilateral like this can make a tessellation as well. So I'm going to make this into one shape with the join button down here. So there's the ability to flip and cut. You can also join two polygons together to make one. So I click join, and there it is. There's my one polygon. And now I can take this and make a tessellation with this shape. I'm just doing the copy feature, and I'm off and running with my tessellation. My students have had a great time making tessellations of all different kinds of shapes. So that's really cool. But I'm going to move on to thinking about nets and prisms and cubes. One of the features we have this summer is the ability to fold a polygon into a net. So I'm going to take this square and put it on the canvas, and I'm going to make 6 of these here. 1, 2, 3, 4, 5, 6, and you may know that this looks very familiar like a net of a cube. And if I click and drag and select all 6 of those, a new button comes up that we haven't talked about here called Fold Net. And so watch what happens here. This is such joy as this happens. I click Fold Net, zoop, and there is the net of that cube. I can unfold it with this slider and stop at any point along the way and move it around as well. And when I click the unfold button, they become the 6 squares again. And so I can envision a great activity for all ages of students of just go build as many nets for a cube as you can. Maybe start with one as a class, and maybe think about, maybe students would build this one and see what happens. Is that going to make a cube? I'll have you think about it for a little bit. I'm going to put 6 up on the canvas. And I just want you to think about which of these would make a cube. I see a few questions in the chat about making classes and all sorts of stuff. I will answer those in a minute. But here are 6 different things that students might think could make a cube. Again, I would not be doing this for students as quickly as I'm doing it now. I would have students build and explore and share. But all right, let's just see what happens. Is that going to make a cube? What do you think? Yeah, there it is. What's going to happen here? Is that going to make a cube? No, it makes like half a box, but you can see what happens, right? You can actually fold it and see if it if it is going to make a cube, and if not, what type of shape it makes. If it's foldable, is this going to make a cube? No, that's also kind of a box, right? But what a great ability for students just to build something and fold it and see what happens, right? And like have them make a prediction and fold it and just go. There's this one. What's going to happen here? Oh, like there's some overlapping going on here, right? You can kind of see the overlap, right? It's like right there's the overlap. And then there are some that don't fold. This is not a valid polyhedron net, right? So that ability just to play and explore. Again, I was talking about how I like to think of this. We like to think of this at Mathigon as just an open canvas for mathematical exploration, right? What a great example of that here, where students can just go explore. In the tile section of 3D solids, there are other examples that are pre-made here. Here's an octahedron. You can build a prism. So many wonderful things that you can do with these that are pre-made. But I think it's just great for students to try building something. Take any of these polygons and build something and see if it folds or not, and then have a great class discussion about what did it make. Have a discussion here. Why isn't that foldable? What happened? What would get in the way as you try to fold that? All right, a few questions I'm just going to answer. Do we have to add individual students to a teacher account class so they have access to canvases? Can you upload your Google Classroom? Yes and yes. So this can be linked with your classes in Google Classroom. If you don't teach in a school with Google Classroom, you can make an account in Mathigon and create a class, and then students can join that class with a class code. Students under 13 can make a restricted account without their first name or last name or their email. They just need the email of the teacher. And all of that, I know I'm going to kind of dodge the question here, but all of that is explained in these 2 videos, right? So this is like a 5-minute video, how to create classes and add students. So I'd encourage you to go watch that. I just made it yesterday, so it's up to date with all the newest features in Polypad. And then in our events and webinars, there is a webinar from about a month ago on all the teacher tools. So just a deep dive into the teacher tools. So those answers are there in tutorials and the teacher tools. I just want to go back to the geometry. I'm quickly running out of time, and I have so many more things that I want to show you. The other thing that is really cool in the geometry section, I'm going to turn on the grid. I'm going to use the custom polygon and make a rectangle. I just want to show you a few other ideas in geometry for students at the elementary age. I might take a square and put it on. I'd fix the vertices here, turn off the background, and just ask students, I don't know, how many blue squares do they think it'll take to fill up the green, right? Make a prediction, talk about it. And then as we explore this as a class, I'm going to lock this so it's just stuck at the back. You know, I might do that and have them update their prediction. Maybe stop there, right? And obviously we can begin to think about the area model of a rectangle just by building. But then I would build a canvas and have students go do this on their own, right? There's so many amazing, you know, quick animations out there where students watch a little square filling up a rectangle. Here they can actually do it. So give them a whole bunch of rectangles on the canvas and have them fill them into squares as they're filling it in. And they might do exactly what I did, where they take this and they might copy it and fill it in, and they're building their understanding of the area model as they copy those rows and fill it in. So cool. I just want to show you some things I've done in 6th grade with triangles and parallelograms. I gave students a canvas just with a bunch of parallelograms, and I said, find the area of these parallelograms. And, you know, they had gotten pretty good with the Polypad tools. This was in the spring, and without me even talking about it. Again, this, you know, was after some use of the Polypad tools, but they just took this on their own. They went to cut. Oh, I missed. I'm going to turn the grid background on so I can cut straight. They went to the cut tool. They cut it right here, and they moved it over there, and they made a rectangle, right? And for years, I've been like giving kids paper to cut out and giving a demo on the board. Here, they went and did it on their own, right? And those brain connections that they were making as they were doing it on their own was so cool. I also had kids take the custom polygon and make it into a rectangle like this, right? And then they took this triangle and moved it over here, and they found the area of the rectangle, that big rectangle that I just made, and then put those together and subtracted that. So cool, right? Same thing can be done with triangles, right? So that ability to cut a polygon, here's a triangle, right? As we explored how to think about the area of the triangle, I had students take this and make it a different color and copy it and just rotate it. And then they made their parallelogram. This was after we talked about parallelograms, and cut it and then move it over here. And they saw that the triangle is half of the rectangle. There are some kids that took this triangle and cut it right down the middle, right? And took this and copied it and moved it over here. So that ability just to cut and copy and move really easily, I think is validating for what kids want to do. And again, I found the power in this site being so inviting to students and so easy for them to use that they're able to do what they actually want. They don't have to cut out the paper and the scissors and the tape and make a mess. Now, there are times where a physical tool is better than a virtual tool. There are lessons I do in class all the time that don't use Polypad, right? But I think there are examples here where I found in class doing it with paper and scissors and tape got in the way of the mathematics. It was just that the passing stuff out was messy. They were so focused on trying to make it work that it got in the way of their brain seeing what was going on. Where here on Polypad, it just happened so nicely. They're able to really dive into the mathematics. I'm seeing some questions about circles. That is a feature that teachers request all the time. It is not there yet in the Polygon tool. I will show you that we do have the ability to make a circle with the construction tools. So under construction tools here, there's a circle, which is more for like geometric construction. So there is not yet the circle as a shape to fold and build a net with a circle, but that's something teachers have been asking about and is on our list of things teachers have requested. There's a lot of things on the list, which is wonderful. We love hearing from teachers about what would be helpful, but that is not there yet. Let me jump to fractions. I have so many more wonderful things that I want to share. I'm going to do just a really, and look at all these things in geometry I haven't even talked about, right? Pentominoes and tetrominoes, tangrams. There's a great task. I want to go back to that question of a teacher who said, what about some pre-made tasks? There's a great task on students building their own tangram puzzle, right? So yes, there are the pre-made tangram puzzles, but this is an idea for a lesson plan where students would take all the tangrams, make their own shape, join the pieces together so it's one polygon, share it with a classmate, and then have them try to solve the puzzle. So that's a nice lesson with the tangram pieces. There are all sorts of great artistic things to do with Polypad, from the Penrose tiles and the nature tiles. We have column tiles. There was just a webinar that some teachers were sharing on Twitter that they attended about the column tiles. There's a link here to learn more about column tiles, tantrics tiles. Go explore the geometry section. There's a whole webinar on geometry from a couple weeks ago that's in the webinar section, so you can go explore that as well. Let's go to fractions. All right, there was a question in the chat about fractions. Let me show you fraction bars. Here is the 1/8 fraction bar that I just dragged onto the canvas. I'm going to put a number line on the canvas just to show that. You can see that matches up to the right size if I get it in the right place. I'm going to lock the number line so I don't mess it up. And so in the fraction bar, so many options under settings. Let me zoom in a little bit here. And under settings, I can hide the number labels. I think I just saw that question in the chat. Oh, this isn't matched up well. Oh, I think I have the wrong. Oh, no, that's correct. I apologize. Right? So I could hide the number labels or not. I could show it as a percentage. I could show it as a decimal rounded to the hundredths place, or I could show it as a fraction. I'm going to keep it as a fraction. You can shade in the fraction bar with the triangle. So I could show there's 3/8, and I could shade it up as I go. I can use this black handle to make the fraction bar bigger or smaller. All sorts of great tools with the fraction bar. I could split the tiles into pieces so I can move them around. And when I move them around, I can again hide the number labels on all the pieces depending on what you may want to do. And a newish feature that we've added, which I'm super excited about. Let me go to the fraction tools, and I'm going to go to 6/8 here. There's 6/8. You can give the fraction a different name by changing the denominator of the fraction. So here there's a rename button. So there, that 6/8 became, what do we got? 8/12 and 16ths and 20ths and 24ths, and I can go down as well. So that 6/8 is getting named all sorts of different ways. There it is as 3/4 all the way up to 24ths. So I had an example to share about how to model addition of fractions with these tools. In the interest of time, I'm going to skip that for now. But in the task page under lesson plans, if you search by fraction, oops, I spelled it wrong. There's a number of activities here to explore how to use these tools with students in developing deep understanding about fractions. So I encourage you to go check out fraction addition or division. There's also a way to merge the colors on the fraction bars. And you can search by standards. Yeah, so here on fraction addition, this is Common Core Standard 5.nf.a.1. If you click on that, it'll show you all of the tasks we have on that standard. So we're continuing to build the library and try to hit a lot of standards. So there might be standards that aren't there yet. If you have ideas of ones that you would like to add to the task library that hit certain standards, go to our Contribute New Tasks page and learn how to contribute your ideas to this page. I know Chad is on the call, and one of his tasks was shut the box that his students came up with. And there is Chad's name. So we'd love to have more teachers on here. I haven't even got to one of my favorite tool types, which is the probability tool. So I'm gonna jump to probability. Again, under fractions, you can click here to read the instructions about fractions. I think the probability and data tools are some of the more powerful tools that we have. I mean, these are all powerful. Is there a way to set the number line to fractions? That is a good question. So let me go back and answer that, because I know I didn't have them matched up perfectly. Yes, on a number line, you can change the number of divisions on a number line. I think that's what I had meant to do, and you might have heard my confusion with the number line. So I'm going to make this number line a width of 20. So there is 0 to 1. And then on the fraction bars, I'm going to put on the eighths. So that makes more sense than what I had there, 0 to 10. All right. Thank you for catching me on that. I was trying to do too many things at once here talking about fractions. So now it is 0 to 1, but you can also change the number of divisions of the number line. So under divisions, if I make it 8, you can see now that those eighths match up right on the 0 to 1 number line. So that's a really nice tool. In the video on fraction addition, I make good use of the divisions of the number lines to try to add fractions with different denominators. So go check that out. There's a question that when you lock an object in position, students are working and if the object moves, what are you doing incorrectly? I don't have a great answer. Maybe it's not saved after you lock it or something. I'm not sure. If you send me an email with the Polypad link that's not working, I would love to see it, and maybe we can try to figure out what's going on. I'll share my email at the end of the webinar in the chat. All right, probability tools. I mean, these are so fun. We have coins, we have dice, we have spinners, all sorts of really amazing, wonderful probability tools. You can put a spinner over here. We have polyhedral dice that I'm just going to put a couple on the canvas here. You can copy dice really easily to make new dice and make new coins really easily. And what is super fun is just the ability to select all of them at once and randomize, and they all spin at the same time, which is super fun. I can double click on a dice and roll it. On the spinner, there's a black handle here to change the number of regions. There's a protractor tool that'll snap nicely to the regions if you want to measure the size of them. And here on the custom spinner, if I click on the black line, it'll add regions, and if I click on a circle, a region will go away. And if I move the handle, I can change the size of that, which is so cool. All right, but I want to show you a couple of these in action. So there are cards, which I'm going to talk about in a second, and then our charts and statistics tool. But let me go to the task page here. And we just added a lesson plan. Here we go. Class openers and math talk. So a number of kind of at the start of class, maybe there's an opener that you're interested in doing. Here's one called What Two Cards that combines fraction bars, although I'm not going to use them for fraction bars, so I'm going to turn off the labels. We have our playing cards here. So I'm going to select all the cards. I'm going to stack them at the bottom. I'm going to stack these playing cards, turn them over, shuffle. Let me just give a recap of that because that was quick. So I have all the playing cards. I'm just back at this canvas that I got in the task page. Select all the cards, stack them up, flip the whole deck over. That turnover flips the whole deck. I'm going to shuffle the cards so they're shuffled up, and I'm going to draw a card. So here's the first card, and then I can double click on the deck to draw a card as well. Here's the second card, works on the balance scale. Then I'm going to take 2 dice and put them on the scale. Of course it's 7, right? So if I get 7, great. I'll turn over the first card and then or actually at this point I'd have students talk about what do they think the 2 cards could be, and they'd have great conversation there. I'll turn over the first one, and then they'll see what the second one could be, and then we would do it again because that was too quick. So let me just show you another example, but it's really easy to do it again. I'm going to turn these over. I can select all of these and stack it. I'm going to shuffle it. I'm going to draw a card and see what happens this time. I'll draw a card. Hopefully it's not 7 again. Oh, it is. It's heavier than 7. So we talk, kids would chat in pairs. Any predictions? What do they think that the 2 cards could be? Depending on the age of students, I might do something like this. Oh, it's got to be more than 7. So let's get those numbers covered up and roll the dice again. And just a fun 5-minute activity at the start of class. More than 5, or the middle of class, or at the end of class. More than 7, more than 2. Let me get some high numbers here. And if I'm doing something like this and not getting high numbers, I can add the third dice on here. All right, it's more than 8. We just saw it's more than 8. Right? I could roll them all again. And I'm going to stop there in the interest of time, but you get what's going on here. Oh, it is less than, what is that? Less than 11. So I'd go that. Oh, it's either going to be 9 or 10, right? And we keep going, and eventually I'd show a card, and it's 6, and let's say 4. Oh, all right, 6 and 4. So super fun. Let me go to the File menu and go to Probability and Data, and I just want to go to the canvas with 100 dice here. So I'm going to do all this, 100 dice, and I think a fun exploration for kids at the elementary level would be to roll all these dice and count how many of each number they get. So I'm going to go to Tiles and Charts and Statistics. This is new. I want to just do an example here of Charts and Statistics. and they're going to count how many 1s, 2s, 3s, 4s, 5s, and 6s they get. So they'd go through and count them. I'm just going to make up numbers because I don't have time to count. Let's say that's 15 and 16 and 18 and 12 and 19 and 20. No way that adds up to 100, but I just wanted to get some data up there on the canvas. And then they can add a chart here, right? So let me just zoom out a little bit to give myself some room, and they can attach this data to the chart, right? So that's how many 1s, 2s, 3s, 4s, 5s, and 6s. And then they can roll them all again. And it's really fun to see all the dice rolled. And then let me put the chart down here and the table up here. You can see it's linked. I can unlink it. Oops, I missed. I can unlink it. And this blue handle, when you drag that blue handle onto the chart, it links the data to the chart. And maybe on the second one, I could label this numbers, and this would be first roll and so on, right? Second roll. And then maybe this time it was 11 and 14 and 18 and 10 and 20 and 21. And again, just making up those numbers. But what is really nice here is if I drag this tab to the left, it saves the data. It's still in the table, but I can just focus on the first roll and see how it changed on the second roll. I can click on the chart. Let me just make this a little bit bigger here. And when I click on the chart, there are some options here. I could go to a row chart. In the bar chart, it can be grouped like this. It could be stacked. So there's the first roll and the second roll. It could be percentage out of 100. So I think there are a lot of websites out there where you can have it roll 1,000 dice and you see the graph depending on what's rolled, but you don't actually see the numbers that are being rolled. I think for students to see the numbers being rolled and count them themselves and then put the whole class data together. Here in a matter of minutes, I rolled 200 dice. In a class of 25, right? 25 times 200 dice is a lot of dice. So that's really, really cool. You can get actual data. I've done this in middle school with pairs of dice, right? With 3 dice and 3 coins. And kids really believe that the probabilities are accurate when as a class they've done 10,000 trials and they see that the expected probability, the expected number of outcomes is really close to what we actually got as a class doing it 10,000 times. And so here in the example section, there's 100 pairs of coins, right? So I've had students talk about how many stars would you expect in these 100 in these 100 flips of pairs of coins. In the task page, there's a new task that we put out around having students explore which type of chart is best for a given set of data. And this, I'm just going to go to the Polypad. This is data that I got from the Olympics. And so here is just a data set of the continents that have hosted the Olympic Games from 1972 through 2021. And so, we could have students choose. Maybe a line chart would be best here. Oops. I don't know. It doesn't really show the data great. Maybe a donut chart would be nice here, right? Pros and cons of the donut chart versus the line chart. So great conversation here about which chart is best for a given set of data. It's real easy to take the chart and put it on the canvas and attach it to the data and see what happens. So I think that's a good task for students to explore. Oh my goodness, it is 5 before the hour and I want to leave time for questions. And I have a few other things that I want to share with you. You obviously can leave anytime, but I have just a few last things to share. A task that teachers have reported is very successful in class. I've used it very successfully in my class, is the Genius Star game. We've made this game with permission from the Happy Puzzle Company. I just want to show you how the Genius Star games works. You spin all the spinners. I'm going to randomize all the spinners, and any of these triangles, so I got a triangle in 48. I'm going to take this gray triangle and put it in 48. Here, this is in 18, so I'll put this in 18. You might need to spin it around, and so on. So I'd put all 7 of these triangles in those numbers, and then you use all these shapes to fill in what's left. And the amazing thing is every possibility has a solution. So this is fun for students to explore on their own. As a class, what I do as a class, I spin it on the projector. I call out the numbers so everyone's working on the same set of numbers, and we have a fun competition about who can get the Genius Star filled in first. And on the task page, let me go to For Teachers, new tab, lesson plans. You can sort by puzzles and games and find all the puzzles and games that we have available on Polypad. There's Blockout, which is a great game. Cover Up, the Genius Star. So go explore all those games. So many wonderful things that are there. I want to go away from Polypad for a few minutes and just share with you the multiplication by heart flashcards made again in partnership with Dan Finkel over at Math for Love. His physical, right along with your question. Thank you. I just saw it in the chat. The physical cards are just being shipped, so I encourage you to go check out the multiplication by heart actual flashcard set that you can buy. But I'm going to go to activities here, and I'm now on my daughter's account, and I'm going to play the multiplication by heart flashcards. She's explored with these for a while, so she has cards for today that are in box E. Those cards in box E, it's been about 6 or 7 weeks since she's seen this multiplication fact. She types it in, gets it right, types it in, gets it right. 3 times 3 is 6. Oh, it little shakes because I got it wrong. Is it 8? Oh, no. That's going to go all the way back to box A. So these multiplication by heart flashcards are based on the theory of spaced repetition, that if a student gets a card correct, they'll wait a day or two to see that card again. If they get it correct the second time they see it, they'll wait 3 or 4 days before they see it again. And as long as they get them correct, the time in which they see the card again gets bigger and bigger. If at any point they get the card wrong, it goes back to box A, and they'll see it again that next time that they go do the multiplication by heart flashcards. There are a number of visuals here. You can see I'm just getting rectangular arrays right now. But if students just want to practice, they can go to the shuffle mode, and in shuffle mode, they'll just get a random set of flashcards. I just want to get to some different visualizations here. I'm just getting rectangular arrays, but there's all sorts of visualizations. I'm going to stop because I do have more to talk about, but I want to show you, there we go. There's a nice representation with the prime factor circles. We've heard from teachers and students, they love that this is not timed, that it's just, you get about 30 cards a day, sometimes 36, sometimes less. It's inviting for students. There's no really penalties if they get them wrong, and it's a good way to connect the visual idea of the numbers with the multiplication facts. If you want to learn more about those, again, all of this is free for teachers and students. On our teacher page, I keep going back to tutorials. There's a whole tutorial on the multiplication by heart flashcards, how they work, the theory of spaced repetition, what options you have as a teacher. On your teacher account, you can see a dashboard of your classes, multiplication dashboard. My son is going into 6th grade. He doesn't need to do them anymore, so he hasn't done any. But my daughter, as I could see her progress along the way. Her last was today, but that was me, right? So that's the multiplication by heart flashcards. We have a number of other activities in the activity page, a timeline of mathematics, an almanac. Factress is a great game to play. It's like Tetris, but with multiplication facts. And the few other things I just want to share with you, and then I will stay around and answer any questions people have, is again, under For Teachers, if you go to events and webinars, you're here on this webinar, so you know how to get there. But we have a super exciting guest speaker series upcoming this school year. So I'm doing another webinar Wednesday, back to school at the secondary level. You're welcome to come on Wednesday night. But our guest speaker series, again, free for everyone, starts at the end of September with James Tanton, Sunil Singh, Mary Kemper, Maria del Rosario Zavala, Dan Finkel from Math for Love, Katronia Ogg, Desiree Harrison, and Jennifer Suh are the 8 speakers that we have in our guest speaker series over the course of the school year. So go sign up for those. I'm really honored and excited to have such amazing mathematicians and educators as part of our guest speaker series, as well as you can sign up for the other Mathigon webinars that we have over the course of the year. We have a couple in October and November, and of course we'll be doing more over the course of the year as well. The other thing we just added today is our community forum. This is brand new. You've probably seen it more than most people. You can go to our community forum, and this is a place to ask questions, share ideas with other teachers, get links to some lesson plans. So here I'm in my account, but I encourage you to go explore. Here's a suggestion from Steve Phelps. It'd be nice to be able to flip over the dominoes, number tiles, prime number circles and stuff so you can use them. Yeah, awesome suggestion, right? So that was just posted. We'll add that to our list of suggestions. You do need to make an account to post something here, and it's different than your Mathigon account, even though it's feels like it's housed in Mathigon. It's powered by Tribe, which is a different company. So you just need to make an account with them with your Google account or an email or password. And that can be a way that you can participate in the community page. But if you just want to go explore by topic, you can go click on elementary or middle school and just go explore what's on the community page. All right. That was so rapid fire, and there are a number of things that I did not even talk about that I was so excited to share, but I want to be respectful of the time. Just in closing, that was a whirlwind. If you are brand new to this and you're like, I don't even know where to begin, again, under tiles, there's a link to a tutorial page, and you could start with Polypad 101, an introduction that talks about how to add tiles, save tiles, change colors, all that stuff. And then in all of the tile types, you can't see them right now, but when you expand a tile type, there's a link to instructions for that specific tile type. So that's a great place to go check out if you are new. And then I'll just show it one more time. On our teacher page, there are the tutorial videos about how to get started as a teacher, really, right? How to make classes, how to add students, how to share polypads to your classes like I just did in the video. There's this first video here that talks about how to add students to Mathigon. If you don't have Google Classroom and you're concerned about student privacy rights and access, this would be a good video to watch. And then here are our past webinars. All right, I want to thank you for joining. I will stay on and answer any questions. I am super excited about this tool being available for teachers and students around the world. I think it really helps students make sense of mathematics at their own pace. They can use the tools as they need them. They can play, they can explore. And the more they do that, and those concepts begin to like make connections in their brain, they may not need the tools anymore. But it allows them to do it at their own pace, to really make meaning and understanding of mathematics at their own pace. And so I've witnessed that in my classroom. I've heard it from teachers around the world that have done that. And so thank you for being here. I'm going to officially end the webinar, but then I will stay on and answer any questions people have. All right. Thank you for coming.